Hello everyone. Today we'll be solving reverse linked list problem from Leetcode. So let's go through the problem statement. Given the head of a singly linked list, reverse the list and return the reverse list. So we will be getting the head of the list. So in this example, we will be given a pointer reference to 1 and we need to reverse the linked list and return pointer reference to 5. So let's go through one example. So for this one, 1 2 3 4 5, we just reversed it like 5 4 3 2 1, and there will be some base cases. So I think the example 3 covers one base case when head is null. So like there is no element, and there is one more base case if there is only one element in the linked list, so we don't need to reverse it, it's already reversed in reverse order. There is only one element, so there is no reversal. So let's write code for base cases. So in that case, we will return the pointer we already got. So for the if there is head is pointing to null pointer, we will return null pointer, and if head is pointing to one element only, we'll just return that element. Apart from that, let's try to solve this one. So we got list 1 2 3 4 5. So what we'll do, we'll define the three pointer variable xptr, that means like previous pointer variable, and ptr and nptr. So by default xptr will be null, so just define at null pointer, and ptr will be containing pointer to 1, pointer to 1, and uh, nptr will be ptr next, like the next element of pointer, and that would be pointer to 2. So what we'll do, we'll change ptr next, like next pointer of current pointer, to xptr. So ptr next will be xptr. So ptr next will move to next ptr. Ptr next will be xptr. So this will be xptr. So 1, then it will be null pointer. So list will be look like something this, so it will be broken into two parts. So 2 3, just remove this one. So what will we do? Okay, this will be next step. Let's keep that lines also. So 2 3 4 and 5. So what I'll do, so initially we just define three pointer variable, that's like initialization part. Initialization. So we'll just define three pointer variable. So in next step, like once these values are initialized, in next step we just point ptr next to xptr. So by default the xptr is 1, so list will be something like this. New list will be this and this. There will be two lists since we got that link broken. And after that we will assign xptr to ptr. So xptr will have reference to 1. Just write, instead of pointer to 1, we can write directly, no, we cannot write technically directly 1, just for simplicity's sake we can write 1. So pointer ptr points to 1, we can write something like that. PTR points to 1 and xptr points to null PTR, and nptr points to nptr points to 2. So this will simplify a bit. Instead of writing pointer to, so nptr points to 2. So here new list is 1 null ptr 2 3 4 5, and we'll move like xptr to ptr. So xptr will point to 1 and ptr, the current pointer still points to 2. In the next step we'll move pointer by one step. So as of now this is xptr and this is also ptr. So what we'll do, we'll just move pointer till here, and so we will just like ptr is nptr, and so in this step it will be like ptr will be 2, ptr 2, and I think that will be all the calculations. So the current state will be something like xptr point to current state will be xptr points to 1 null and ptr points to 2 and xptr points to 1, but the state of list will be the same. In the next step we'll repeat the same. So xptr so ptr, okay, in the next step what we'll do, we'll get nptr. So nptr will be, let's delete everything and we can start like again calculation just to remove confusion. So I'll just remove the initialization code. So currently we have this list and ptr points to 2 and xptr points to 1. In the next step what we'll do, we'll again do ptr next. First we'll get nptr, so nptr will be like ptr next, that would be 3, and ptr next, then we'll update ptr next to xptr. So and now list will be so this is not new list now, so list will be, so 2 will point to xptr, that is 1, so 2 1, and 1 points to null pointer as of now. And since now this link is broken, remaining list is only 3 4 5, so that 3 4 and 5, 3 4 and 5. And now we'll do again like assignment steps. So xptr will be ptr and ptr next, sorry, ptr will be nptr. So in the next step, so now ptr points to again do like remove previous calculation and check the initial check the updated values. So as of now ptr points to 3, ptr points to 3, that was nptr first, and xptr points to 2. So xptr has a reference to this new list we are creating, and the ptr has a reference to this list. So what we'll do, we'll get like nptr again, so nptr will be 4, and we'll do like ptr next to xptr. So after that 3 will append over here, and this link will be broken. So this link will be gone since we assigned like ptr next to xptr, so this link is gone, and we'll update the pointers. So updated pointers will be xptr will point to 3, xptr will point to 3, and ptr will point to 4. And now again we'll get next nptr, and nptr will be 4, and nptr will be 5. And in the next step we'll do again like ptr next is xptr. So in this step, so now list will be like 4 will be appended here, and this link will be broken. And next step, like we'll update the xptr, ptr to ptr, and ptr to nptr. So updated values will be xptr4 and ptr5, and ptr we need to calculate like in next iteration. So we'll in next step what we'll do here we'll get like nptr. So nptr will be null pointer, and ptr next will be xptr. So this loop will be broken, this link will be added over here, and 5 will be gone. And so this line is executed, and for the next line we'll move like xptr to ptr. So xptr will have 5, and ptr will be updated to nptr. As of now nptr is null, so it will be moved to null, and at the end we will have like reference to 5 in xptr. So we'll just remove we'll just return this reference to 5, that is xptr, and we'll keep running this loop until like ptr is not null. Ptr, this will be like base condition for our loop. So let's write some code. So we'll do like list node, just define 3 pointers. We'll keep iterating until like ptr is not null, and we'll just define like xptr also null pointer initially. And what we'll do, we'll create a dynamic value of nptr, that will be ptr next, and we'll do like ptr next is xptr, and xptr will be ptr, and will be next nptr. So after the loop we'll return this next pointer. Okay, there is some error, deadly signal error, unknown address causing memory. Let's like check the code again. Okay, we haven't initialized like ptr, so we need to like initialize like ptr. So by default it's supposed to be pointing at 1 if we have list like 1 2 3 4 5. So this got reversed. So let's try to submit the solution. Yeah, this works. It's faster than 86%, 88.6% solutions, and it uses less memories. So also analyze the time complexity and space complexity for this one. So for time complexity, let's assume like size of list is n. So for that, time complexity will be order of n, since we are using only one loop over here. So we are iterating through entire linked list one time, and since we are using only 3 pointers, so we are not using any additional space that is directly proportional to n. So that would be power of 1. So that would be it for the video. If you like the video, please hit like button in the video, and please also subscribe to my channel. Thank you. Bye.